Elon Musk has taken viewers inside Tesla's factories many times, showing how advanced automation can transform raw materials into finished vehicles in a remarkably short period of time. But now, Tesla is pursuing a manufacturing breakthrough that could challenge the traditional way cars have been built for more than a century. The possibility of producing a vehicle in dramatically less time is attracting enormous attention. And what makes this especially interesting is that Tesla is not simply introducing another new vehicle, battery, or humanoid robot. The company is attempting to redesign the entire manufacturing process itself. That could become a serious concern for traditional automakers. For over 100 years, most car manufacturers have relied on a familiar production model. Thousands of individual components are manufactured separately. Robotic systems join many of those parts together, and workers and machines gradually assemble the vehicle step by step until the finished car leaves the factory. Tesla wants to move away from that traditional approach. Elon Musk's long-term goal is not simply to create a better automobile. He wants to create a more efficient factory. If the manufacturing system becomes faster and less expensive, the cost of every vehicle produced can continue to decrease. Eventually, the biggest advantage may not come from the vehicle's design or advertising. It could come from the manufacturing process itself. So what exactly is Tesla changing inside its gigafactories? Why does Musk believe the company's new production strategy could transform the automotive industry? And how could Tesla eventually build vehicles in an incredibly short amount of time? For decades, the automotive industry has followed a relatively simple manufacturing principle. A vehicle is broken down into hundreds or even thousands of individual components. Those parts are produced separately and then brought together on an assembly line. They are welded, bolted, installed, inspected, and adjusted in a carefully organized sequence. This method has been refined over generations, and major automakers around the world still rely on versions of the same basic system. But Elon Musk asked a different question. If many smaller parts eventually need to be joined together to create one larger structure, why not produce that larger structure as a single piece from the beginning? That idea helped lead Tesla toward one of its most important manufacturing innovations. Instead of assembling dozens of smaller stamped metal pieces to create parts of a vehicle's structure, Tesla began using enormous casting machines known as the Giga Press. Depending on the application, these machines can generate thousands of tons of clamping force, with future systems potentially becoming even larger. The process allows molten aluminum to be transformed into a large structural component in a single casting operation. The result is significant. Dozens of separate components and hundreds of welds can potentially be replaced by a much larger single piece. At first, this may sound like a simple engineering improvement, but the consequences extend throughout the entire factory. Fewer individual parts mean fewer assembly steps. Fewer assembly steps mean fewer welding operations and fewer robotic systems required for those tasks. Tesla has been able to reduce the number of robotic welding systems needed in certain areas after introducing large-scale casting technology. Fewer connections also create fewer opportunities for manufacturing defects. A simpler production process can reduce assembly time, lower costs, and allow vehicles to move through the factory more quickly. These are the kinds of changes that customers may never notice when they purchase a car. However, they can have a direct impact on the cost of manufacturing each vehicle. And the Giga Press may only be the beginning. Tesla has also presented another major manufacturing concept known as the Unboxed Process. Traditional vehicle production generally moves a car through a long sequence of stations. Each component is added in order as the vehicle progresses from the beginning of the line to the final assembly stage. Tesla's alternative approach is to divide the vehicle into several independent sections. Different parts of the vehicle could be assembled simultaneously in separate areas. The front section could be produced in one location, the rear structure in another, while the battery, interior, and other major modules are built at the same time. Instead of creating the entire vehicle in one continuous sequence, Tesla aims to manufacture multiple sections in parallel. These separate modules would only come together during the final stages of production. According to Tesla's projections, this approach could significantly reduce the amount of factory space required, while also lowering manufacturing costs and increasing production efficiency. The most important goal is to reduce wasted time. When different sections are being produced simultaneously, the entire factory can potentially operate more efficiently. Tesla has indicated that future vehicles, including the Cybercab, could become important examples of this new manufacturing strategy. The company is also targeting much lower manufacturing costs for future vehicles, with the possibility that costs could fall even further as production volumes increase and the process becomes more refined. The Giga Press and the Unboxed production strategy represent two major parts of Tesla's long-term manufacturing plan. While large casting technology is already being used, the full unboxed system is still being developed and optimized for large-scale production. But once the major structural components have been created, they still need to be transformed into the body of a complete vehicle. This is where the body shop becomes one of the most important areas inside the factory. The body shop is often considered the center of vehicle manufacturing because this is where large structural components are joined together. Compared with final assembly areas, the body shop is usually much more heavily automated. Large numbers of robotic arms can operate continuously, positioning components and performing thousands of joining operations with extraordinary precision. This is the kind of environment that explains Musk's description of a factory as a machine that builds machines. Every movement is programmed, every operation is coordinated, and timing is measured with extreme precision. Once the components are correctly positioned, Tesla uses several different joining methods depending on the specific part and structural requirement. Resistance, spot welding, can secure metal components at thousands of locations. Laser welding can be used in areas where greater precision and cleaner joining are required. Tesla also uses strong structural adhesives to improve rigidity while helping reduce vibration and unwanted road noise. By combining different joining technologies, the company can create vehicle structures that are both strong and relatively lightweight. This structural approach also contributes to vehicle safety by helping create a rigid passenger compartment capable of managing crash forces. But robots offer more than speed. One of their biggest advantages is repeatability. Even the most experienced human technician can experience fatigue after hours of continuous work. Small variations can eventually appear. A robot, however, can repeat the same movement thousands of times with extremely consistent precision. That consistency helps ensure that every vehicle body leaving the production area meets the same manufacturing standards. This is one of the main reasons manufacturers invest so heavily in industrial robotics. However, the vehicle is still far from finished once the body shop work is complete. The body then moves to the paint shop, which is one of the most carefully controlled sections of the entire factory. Even a tiny particle of dust can damage the final finish. For that reason, temperature, humidity, and air quality must all be carefully managed. The process begins by thoroughly cleaning the vehicle body to remove dust, grease, and other contaminants. The body then receives an electrocoating treatment designed to protect exposed metal surfaces from corrosion. This coating can reach areas that would be difficult to cover evenly using conventional spray methods. The result is an important layer of protection against moisture, road salt, and long-term corrosion. After that, primer is applied to create a strong foundation between the metal structure and the exterior paint. Robotic systems then apply the color layer, followed by a protective clear coat. Automation helps maintain consistent paint thickness across the entire vehicle. The painted body then enters a curing process where controlled heat allows the different layers to harden properly. The final result is a smooth and durable exterior finish designed to withstand years of exposure to weather and road conditions. However, future Tesla vehicles could potentially change this process as well. The Cybercab, for example, has been associated with Tesla's efforts to reduce or redesign traditional manufacturing steps. If color and protective finishing can be integrated into the structural production process, the need for a conventional paint shop could potentially be reduced. This highlights a much larger shift taking place across the electric vehicle industry. The competition is no longer based only on range, acceleration, or software features. Manufacturing cost is becoming increasingly important. The company capable of producing vehicles at the lowest cost has more flexibility. It can reduce prices, expand its market share, and continue investing in new technology. Tesla has repeatedly used pricing changes across different markets to put pressure on competing automakers. If the company's next-generation manufacturing strategy performs as planned, its cost advantage could become even more significant. But there is an important lesson from Tesla's past that should not be forgotten. Elon Musk once attempted to automate too much of the company's production process. During the Model 3 production ramp, Tesla set an extremely ambitious target of producing thousands of vehicles per week. To achieve that goal, Musk pushed automation far beyond what many companies had previously attempted. Robots were assigned to handle tasks that had traditionally been performed by human workers, including moving components, installing certain parts, and managing materials between different stations. In theory, the approach appeared logical. Robots do not get tired, they do not need traditional breaks, and they can perform repetitive tasks with remarkable consistency. But the real-world situation was much more complicated. Robots performed extremely well when handling rigid and precisely positioned components. However, they struggled with flexible materials such as wiring harnesses, insulation, and other parts that can bend or change shape. A small alignment problem could create a chain reaction that disrupted multiple steps further down the production line. The result was a series of production delays and factory stoppages. Tesla's actual output fell far short of its original ambitions. Musk later acknowledged that excessive automation had been a mistake and admitted that human workers had been underestimated. It was an important lesson for the company. Automation is not automatically the same thing as efficiency. The goal is not to replace humans with robots everywhere. The real objective is to use each one where it performs best. If a human can complete a task more efficiently, more flexibly, or more affordably than an expensive robotic system, then automating that task may not make sense. Tesla gradually began redesigning its manufacturing strategy around this idea. Robots are used for heavy, repetitive, and highly precise work. They are particularly useful for welding, lifting large vehicle structures, moving heavy components, and operating massive casting systems. Human workers, meanwhile, remain valuable for tasks that require flexibility, dexterity, judgment, and the ability to respond to unexpected situations. During the Model 3 production ramp, Tesla learned that simply adding more robots did not automatically make the factory faster. In some cases, a single malfunctioning machine could stop an entire sequence of operations. The company sometimes faced delays while waiting for replacement components, leaving unfinished vehicles sitting idle. Musk eventually acknowledged that the capabilities of robots had been overestimated, while the flexibility and problem-solving skills of human workers had been underestimated. That experience helped reshape the way Tesla approaches factory automation today. Rather than automating everything, Tesla is attempting to create a balanced manufacturing system. Machines handle the tasks they are best at, while people continue to perform work that requires adaptability and human judgment. The result is a manufacturing strategy built around efficiency rather than automation for its own sake. And that may be the real revolution taking place inside Tesla. The company's biggest advantage may not come from one single machine. It could come from combining large-scale casting, parallel production, advanced robotics, human workers, artificial intelligence, and a completely different factory design into one integrated system. If Tesla succeeds, the future of automotive manufacturing could look very different from the factories that have dominated the industry for the past century. That's the end of this episode. If you enjoy seeing how Tesla turns ambitious ideas into real machines, make sure to leave a like and subscribe. We'll continue exploring the engineering, technology, and manufacturing systems shaping the future.